All right, I'm going to go through and do some examples, and we're going to focus on examples where we have the second case where we have a repeated root. So first example, suppose I have a differential equation in this form. It's constant coefficient, it's homogeneous, it's linear. So I assume a solution of this form and ask, what does this imply? So I'm going to take that and plug it into my equation. So I need to first find the first and the second derivatives. And when I plug that in, I'm going to have x double prime minus 2 times x prime. Oops, that should be nt here, sorry. Yep. Oops, times n plus x is 0. I can factor out an re to the nt from every term. So I get n squared minus 2n plus 1 is 0. I don't want r to be 0, so I can factor that out or ignore that, which implies that n squared minus 2n plus 1 is 0. And now I'm just going to use quadratic equation. I'm going to have minus a minus 2 plus or minus square root of minus 2 squared minus 4. Coefficient on n squared is 1 times 1 all over 2 times 1. So this becomes 4 minus 4 is 0 over 2, and 2 over 2 is 1. So I only have a single root, and the reason I have a single root is because the thing underneath the square root is 0. You may have also looked at this and recognized that you can factor it, and if you saw that, that's fine. You can do that. But this means now my x of t is going to be r1 times e to the t, but because it's a double root, I have to multiply basically the same thing times t, but I could have a different constant there, and this is now my solution to the equation. All right, let's look at a second example. In this second example, we have x double prime plus 4x prime plus 4x equals 0. And we're going to be given that x of 0 is 3 and x prime is minus 2. So I want to find the solution in this case. So in this case, there should not be any constants when I'm done. If there's a solution, it should be unique. And first thing I'm going to do is I'm going to use this to find the general solution, and then I'm going to use this to get the specific solution. So this is constant coefficient. It's linear and it's homogeneous. So I'm going to assume x of t is re to the nt. I'm going to plug it back into my equation. So I need to take the first derivative. I'm going to get re to the nt times n. Take the derivative of that to get the second derivative. So I get re to the nt. Now I get n squared. So when I plug it into here, x double prime is re to the nt n squared. 4 times x prime is going to be 4 times re to the nt times n. And then 4x is going to be equal to that. And notice re to the nt, re to the nt, re to the nt is in each term, so I can factor that out. And when I factor that out, what's left is n squared plus 4n plus 4. I don't want r to be 0 because that would mean that x is 0, and that's not helpful. So the thing that's left is that. Now in this particular case, I notice I can factor it, so I'm just going to go ahead and factor it. And notice I only get a single solution. So that means one solution is r1 e to the minus 2t. Because it's a single root, I'm going to basically take that and multiply by t, with a different constant. So my general solution is in this form. And I am going to now use this information to figure out what is the value of R1 and R2. And so to do that, I'm going to need to find a derivative for this. So I'm going to do that first. To use the product rule, derivative of t is 1. Derivative of e to the minus 2t is e to the minus 2t times minus 2. Now the derivative of this term is r1 e to the minus 2t times the derivative of minus 2t, which is minus 2. Okay, so now I'm going to plug in x of 0 equals 3. So when I plug in t equals 0 into x of t, I should get 3. So everywhere I see a t in this expression, I'm going to replace it with a 0. R2 times 0 is just 0. E to the 0 is 1, so this is just R1. So I get that R1 is 3. Now coming to this expression for x prime, I know that when I plug in t equals 0 into x prime, I should get minus 2. So everywhere I see a t in the x prime equation, I'm going to plug in 0. So what happens? E to the 0 is 1. R2 times 0 is 0. E to the 0 is 1, so I'm going to have minus 2. I know that R1 is 3. So 3 times minus 2 is minus 6, so I get R2 plus 6. Oops, sorry, that should have been a plus. I was thinking ahead, so this should be R2 minus 6. So R2, if I add 6 to both sides, R2 is 4. So my specific solution, coming back to, where is it? Here, is R2, so I get 4t e to the minus 2t, plus R1, and I said R1 is 3 e to the minus 2t. So that is my specific solution to the original differential equation. Okay. Let's look at another example. This example is going to be a third order equation. So it's going to be an algebraic mess. So it's x triple prime minus 4x double prime minus 3x prime plus 18x is 0. Because there's 3 derivatives, I know I'm going to have 3 unknowns or 3 functions to work with. It's constant coefficient, it's linear, and it's homogeneous. So I'm going to assume x equals re to the nt. Now for these derivatives, I'm just going to do them quickly because at this point I'm assuming we're starting to see what the patterns. So the first derivative is re to the nt times n. Second derivative is re to the nt times n squared. And the third derivative is re to the nt n cubed. And you should be able to show that on your own at this point. I'm going to plug this into the equation. So x triple prime minus 4x double prime minus 3x prime plus 18x is 0. That's from my original differential equation. Just as before, I have an re to the nt everywhere. So I can factor that out. So I have an n cubed minus 4n squared minus 3n plus 18. I don't want r to be 0, so I can divide that through both sides, which implies that n cubed minus 4n squared minus 3n plus 18 is 0. All right, I got to find at least one root. Let me just make some guesses here. If n equals 1, I plug that into this equation. I get 1 minus 4 minus 3. That's not 0, so that doesn't work. Let me try n equals minus 1. So n cubed, minus 1 cubed is minus 1. Minus 4 times minus 1 squared. Minus 3 times minus 1 is plus 3. And that's not 0. This is getting old, but let's hope this works. Let's try n equals minus 2. So minus 2 cubed, minus 4 times minus 2 squared, minus 3 times minus 2 plus 18. It's minus 8. So this is 4 times 4 is 16. Minus 3 times minus 2 is 6, plus 18. So what is this? This is minus 24. Plus 24 is 0, so n equals minus 2 is a solution. That means I can factor out an n minus a minus 2, and I'm going to express it as n plus 2. So I'm going to do the algebra. My original equation comes from here, n cubed minus 4n squared minus 3n plus 18, and I believe that n plus 2 is going to factor. If I get down at the end of this and the remainder is not 0, I made a mistake either in the algebra or here. So let's just go through and do it. To get n cubed, I multiply n by n squared. And now multiplying through, I get n cubed plus 2n squared. N cubed minus n cubed is 0. Minus 4n squared minus a 2n squared is minus 6n squared. And then I bring the rest down. To get 6n squared, I multiply n times minus 6n. So n times minus 6n is minus 6n squared. Minus 6n times 2 is minus 12n. So this minus 6n squared minus a minus 6n squared is 0. Minus 3n minus a minus 12n is plus 9n. I bring that down, and to get 9n, I multiply n by 9. So I'm going to get 9n plus 18 is 0. So that's good. So that means I can write it in the form of n plus 2 times n squared minus 6n plus 9. And I can just focus on this. I can factor this. In this case, if you do not see that you can factor it, just use the quadratic equation. Don't mess around. I can recognize, though, that that is n minus 3 quantity squared. So that means n equals minus 2 or n equals 3, but n equals 3 is repeated twice. So what does that mean? That means then for my differential equation, I had x triple prime minus 4x double prime minus 3x prime plus 18x is 0. I get n cubed minus 4n squared minus 3n plus 18 is 0. And I can factor that as n plus 2 times n minus 3 squared. So from here, I get r1 e to the minus 2t. This implies n equals minus 2 is a solution. This implies that e to the 3t is a solution. And now, because this is a repeated root, I need to take the same thing that I got before and multiply by t. By the way, notice this is decay, this is growth, and this is growth, but it's also even more because you're multiplying the thing by t. So as t grows, this e to the minus 2t gets close to 0. This term, e to the 3t, gets really big, but t times e to the 3t is going to get even bigger. So in this case, my dominant term is t e to the 3t, and I'm going to see exponential growth example, like t e to the 3t. X triple prime minus 4x double prime. So again, if you're 3x prime, on a particular question, 18x, it's going to be a common thing that you're given an equation like this, asked to find the solution, either general or specific, but also you should be able to explain what the general behavior is going to be over the long term. It's a very important skill to be able to look at that and determine. Sorry, last example. Fourth derivative of x minus x triple prime minus 3x double prime plus 5x prime minus 2x is 0. This is fourth order, so I'm going to need to have 4 solutions. It is constant coefficient. There's just constants in front of each term. It's linear, and because of the 0, it's homogeneous. I'm just going to make a guess. If it doesn't work, we move on, but I'm going to try that. All right, I'm not going to go through all of this because this is already tedious. When you take each derivative, right, the fourth derivative should have an into the fourth, r d and t, into the fourth. You should be able to show that. And what I get in the end is a quartic, or fourth order polynomial like that. And if you notice n equals 1, you can have 1 minus 1 is 0, minus 3 plus 5 is 2, minus 2 is 0. So you should immediately see that n equals 1 is a solution. You should be able to go through and factor it all out. I'm not going to go through all of that. But after you go through and go through all the motions, you should get that n to the fourth minus n cubed minus 3n squared plus 5n minus 2 can be written as n plus 2 times n minus 1 cubed. This is a single root. N equals minus 2. This is a triple root, and n equals 1. So I need to get 4 solutions here. This is going to give me 1, and I'm going to have to build 3 out of this because it's a triple root. So for my x of t, this single root is going to give me r1 e to the minus 2t. This n equals 1 is going to give me r2 e to the t. And what you end up doing, if you go through and do the reduction of order, you'll get exactly this. But for the next one, we're going to do what we did before. We take our previous thing, multiply by t. And for the next one, I can take this previous one and multiply by t again. So my general solution is going to look like r1 e to the minus 2t plus r2 e to the t plus r3 t e to the t plus r4 t squared e to the t. And you should recognize that this gives us decay, growth, growth, growth. And for large t, the exponential terms are going to dominate, but an exponential times t squared is going to be the biggest. So the dominant term is going to be t squared times e to the t, and our solution is going to grow like t squared e to the t.